So welcome to our first of many workshops of this year. This workshop is called Chat with Your Data. I'm Chase. I'm the Technical Marketing Manager focused on unified analytics, so HPE Ezmeral Software stack. Today's presentation is brought to you by HPE Ezmeral Software, as well as Intel to do a partnership to talk about this workshop, Chat with Your Data. Questions will be for the end. We've got a lot of content to go through. We'll try, we're going to have a blog post that goes with this for a technical brief to go deeper. If you want to go deeper, as well as the code is openly available, I'll point you towards that. So if you feel like you didn't get everything you need to go maybe build your own prototype or maybe just explore these concepts, no problem. We'll be available afterwards and we'll put you to some additional ways that you can consume this information, what models you're using, etc. So awesome. So HPE Ezmeral Software Demystified. We're going to be using this platform, so let's make sure we talk about it and call out all the tools we're going to be using. The goal of this analytics platform that we're developing and we're continuing to leverage is to give you the ability to develop, serve, operationalize end-to-end machine learning and artificial intelligence workloads and applications, so smarter applications, no matter the scale. And when I talk about HPE Ezmeral, and when we talk with customers, I don't know, did my video leave? Hopefully my video didn't disappear. We say it's an ecosystem managed open source solutions integrated into enterprise-ready machine learning platform backed by HPE and of course powered by Intel Xeon scalable processors. Perfect. So let's break this apart, right? Let's take that again. So again, we'll go to that previous slide. Just want to make sure my camera was working. So an ecosystem of managed open source solutions integrated into an enterprise-ready machine learning platform backed by HPE and powered by Intel, all right? So when I say an ecosystem of managed open source solutions, I truly mean an ecosystem of all sorts of communities and working groups and combined together to make this platform, right? I think we've seen in the market, and I know we see in the market, there's a lot of exhaustion of a la carte platforms. People don't want to just say, here's a feature store, here's a model endpoint, you figure that out. In fact, I have a lot of conversations with customers that say, listen, I want this to be end to end. We all know, all engineers know that context swapping is incredibly expensive, and that is the same with your brain, and then the same with collaboration. So how can we have these tools that target certain personas, bring them together, and give them a way that we can collaborate and develop better applications quicker, right? We can respond to the demands of the market or the demands of our prototype or whatever. And that's where we say we now have an integrated solution, right? So this is open source tools that we have integrated together so that when you start to use a different tool, and I'll show you this in our demo, you shouldn't feel like you're in a new world, right? You shouldn't say, I've left my platform. How do I access this system? How do I log into this system? How do I manage the policies for accessing things? You know that you've been given what I've called kind of a lab as a service, right? Where you can get everything you need to, if you're a platform engineer, present the correct tools, based off your policies to your teams. If you're a data scientist, you can start to say, hey, how do I go from prototype to hardened and pinning my requirements? You have that reproducibility, replicability play. If you're a data engineer, you can handle all the plumbing, and you know that everything's going to be available so that you have an integrated solution. So you can not only deploy the workloads that we're supporting, right? So we're supporting KubeFlow, we're supporting MLflow, but then you can develop prototypes and start to build your applications and your endpoints on top of that, knowing that you have a strong foundation to do so. And of course, without compute, you're stuck, right? Software is phenomenal, but you need cycles to actually run the software, right? And it's kind of, you hear the joke around serverless, right? It's like, well, it's got to run somewhere. And I come from an infrastructure background, so it's like, yeah, it's got to run somewhere, and it's hard, and there's a lot of complexity into that. And that's where not only does Intel come in providing the tools, right, the actual CPUs, right, and all the architectures that they work on, but they actually have another software layer. So our current demo today, we're gonna serve a model, and we're actually gonna not use anything special to inference it. And you're gonna see it's gonna take a really long time. This is because we're trying to show a prototype, we're trying to make this quick to show you how you can quickly experiment. But Intel has a lot of cool software out there using a lot of tools that are gaining a lot of traction, such as Ray and Dask, to help you inference the way you want to, build your network the way you want to, inference on a CPU in a really smart way so you'll get the performance you need. So I just wanted to make sure that I called these out. And if there's interest in doing a future workshop where we talk about these different solutions, phenomenal. But hey, there's some awesome libraries out there and some awesome projects that Intel is supporting. So I just wanted to make sure that we called that out. And of course, when we say backed by Hewlett Packard Enterprise, what does that mean? That means that we're providing support. And by support, we need not only break-fix support, but simplified development and lifecycle management or deployment and lifecycle management. Anyone who's been in the open source world knows that getting a strong opinion and a validated opinion on how something upgrades, right, or how you handle API changes can be really hard. Sometimes it feels like you're herding cats, right? Who do I talk to? How do I reach out with the community? Well, let us do that, right? Let us say, this is a battle-tested way to upgrade. Here's the changes and here's how they impact you. And by the way, if they do impact you, contact us and we'll make sure that we can help you with your integration work. We've taken Kubernetes and we've abstracted it away. I'm a huge fan of Kubernetes. I think Kubernetes is an intelligent platform for managing specifically machine learning because of the scalability, because of the way to check things in as data versus having to write all this configuration as code. I think there's a lot of really cool things you can do with Kubernetes, but Kubernetes is the engine, right? You just want to submit a job and have it scale up and down based on how you've determined your application can scale. You don't want to understand, or not necessarily understand, but you necessarily don't want to handle the intricate details of doing that or writing the code to do that. You just want things to scale and adjust based on how your application responds. So we've hidden Kubernetes from you. We've abstracted it away. This ecosystem isn't done. I think we all know that machine learning is at the bleeding edge here. And one day it was feature stores, the next day it's LLMs, and it's going to be serverless, and all these different ways as we continue to experiment and find the best way to serve these applications as they start to really take over the world. So this ecosystem is growing. This is not it's not here's Ezmeral Software, we're done. There's plans to bring in more open source projects. There's plans to continue to track and grow the projects we're supporting today. And that's really the goal. We're also able to be deployed on-prem. The demo environment that I'm going to show you is actually deployed in one of our data centers or in any major cloud. Again, using the power of having either HPE validated compute platforms on-prem or running in the cloud because it's Kubernetes, right? We should be able to abstract things away. But hey, when you're running in your data center, you want to make sure that you're running on hardware and networks that you know and you have someone to call. And that's really what we're building here. So enough about HPE and our sponsors, but let's talk about today's workshop. Chat with your data. Here's your decoder model pun, data dialects decoded. We're going to start to talk about how to build a chat application. So the goal of this prototype here, our kind of test simulation here, is to build an LLM-based question answer system for private documents. So this is like the super zoomed out level. User asks question, magic AI black box that we're going to reveal, goes to documents, gets an answer, right? And the idea is that it gets an answer that is not the Wild West. I'm no longer, we're past the days of just asking Google. We're past the days potentially of just saying, hey, GPT, you've been trained on literally everything. Anyone who's been on the internet knows that's probably a bad idea. Let's take documents that we've written, we've maintained, we've controlled, right? We have some explainability here, and let's have the model be able to say, I answer your question based on this, and here's my outcome. And then you can iterate from there. So we'd have our source controlled documents, we have our source controlled model and our code, and we can really start to tune it and have more control over how our model responds, right? Which is a really hard problem. And everything I just said, here's the technical business speak, right? We can have the precision, we can have swift knowledge access, and we can have user-friendly interaction. You can just ask someone to, instead of the kind of common response of, hey, did you check the documents? You can say, hey, did you ask the documents? And that's the goal here. So there's a lot of moving pieces here, and we're going to just quickly run through them. Again, I'll show you that there's a GitHub. We have a technical brief, blog post that'll go deeper and deeper and deeper. So there's all sorts of ways to consume this. But here's the high-level overview. So in order to get it so that we can actually have our documents be computer readable and we can calculate the distance between them and see actually what's relevant, right? We don't want to just say, here's every document. We want to say, here's the relevant documents, build your answer off this. Just like for a person, you'd hopefully say, hey, check out this chapter or this section of documents to answer your problem. You want to be specific. You don't want to be hunting and pecking and just translating everything. So we have an encoder model that's going to take all of our documents and embed it into a vector and allow it so we can actually query it. Again, this is all retrieval augmented generation, or RAG, as you might have heard. This is what the whole thing is. So we just put RAG there, but this whole workflow is RAG. So we're going to have the encoder model that's going to encode the private documentation into a vector. Now, once we have these vectors, that's great, but we can't just load them in memory. What happens if they disappear? So we have a vector store. We have a vector store that we can query and say, give us the relevant documentation, do the calculations between the vectors to tell me what's relevant in vector space. Not only that, but since this loads it in memory and is quick, we have MLflow, which is we're using for artifact storage. So it's actually fronting S3 for us. It's fronting some object store for us. MLflow is great. We'll do a lot with MLflow in future workshops, but MLflow will give you ways to store any artifact. So we'll look at it in a sec here, but you can do models, you can do some lineage stuff, you can just drop things in an object store. That's our goal here. So we're using MLflow for artifact storage. We're going to use KServe, which is a phenomenal project. Really close, worked really closely with KubeFlow. It was KServe, and now it's back to KServe. And that's a way to framework agnostic-ish serve a model in a serverless way. So you can tune and say, KServe, this is how you scale and fail and iteratively deploy my model. And again, we're going to be deploying this using CPUs, right? So Intel Xeon scalable processors is what we're using to inference and to run all this code, right? We need something to run it. The integrated development environment that you're going to be playing around with, or that we're going to be showing off, is KubeFlow notebooks. And KubeFlow notebooks, I describe them as managed Jupyter. You can use VS Code, you can use R, Studio, whatever you need. But the point is it gives you a way to build these servers and pin your requirements and present these environments so that you can just select whatever image you want. No matter where you are, you can spin up and know that you have all the requirements. And then once we have all the stuff, this is great, but I just showed you how to write code and I showed you how much computer speak. Well, now we have a large language model to give you that actual natural response. So there's an application that a user can just ask a question to. The language model is going to take all the stuff we just discussed and give it to you in a natural response. Just like if you were asking me a question, right? I'm not going to maybe just highlight the document and copy paste it. I'm going to try to take you along for the ride and say, this is how this all works based on the documentation. The technical flow, again, we'll be able to give you the slides, but this is kind of what I just walked all through. Embed documents, blah, 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 vector store, predictor, transformer, here we go. And the end result is an actual application that we've imported and served. So I'll show you that you can actually import an application into Ezmeral. We imported this application, and we can start to ask our LLM deeply philosophical questions or song references, depending. I actually just thought this was a song reference, and I learned the origin of that comment, and get a result, right? So before we dive into, I just want to give a shout out to Dimitri. He's one of the architects on the content team. I'm only one of many people working on the content team. There's a lot of moving pieces. And because this is supposed to be a collaborative solution, this is supposed to be a platform, different personas can work within it and get results. So shout out to another member of the content team. He's phenomenal. Hopefully if you guys get hands-on with the product, you can work with him. But he's been developing not only this demo, but there's a ton of other demos where we do fraud detection, et cetera. So there's a whole team backing and supporting this when you guys want to go further and solve your problems. Some important callouts. I'm going to start the inferencing, and then I'm going to go switch contexts on you. Not switch context, but switch over to different pieces so you can understand how this is all working. Because currently, intentionally, inferencing is going to take a really long time. It takes like 500 seconds. But that's because this is supposed to maybe be your first pass. It's supposed to show how you can quickly get up and running with a prototype. And then you can start to discuss things like pipelining or pinning requirements or using those Intel libraries I just discussed previously to really optimize your inferencing. Because just using things out of the box can be great, but there's a lot of ways, and because this is supposed to be extensible, that you can begin to fine tune and optimize how your workloads are actually going to run and deploy. So let's finally get to the demo here. So let's decipher the data dialect. So first things first, let's take a look at what is Ezmeral Unified Analytic. All right, this is where I'm going to get everything built and running. This is where we're going to show you everything. So when I say context, not switching your context, right? I want to show that all of these different tools are being deployed on the software. And we're only leveraging a small subset of them, but based on how much you consume them, that's really how this all works. So of course, I'm going to be showing you KubeFlow. I'm going to be showing you MLflow. We're going to show you how to import things. So really, it's all within the context of this software. You can click here and see data scientists or data science. We're going to look at our model registry, which is MLflow. If we actually go to experiments, you'll be able to see my documents, my embedded documents that are being stored on MLflow. We can also go look at something that I think is really cool, which is we can look at our actual served endpoints. And these are, this is the age of the endpoint, but underneath the endpoints and how Kubernetes and services work, these endpoints can stay up, but you can be progressively deploying models on the back, and you can do A/B, you can do whatever, and the endpoint will stay up, but the actual model and the API and the intelligence behind the application, that can be updated. Also, you can, of course, import your own application because the model is not the entire application. Hopefully we all know that the end user has to consume something. We're not just going to say, hey, create a request and hit that model for me and get me an answer. The end user will be like, that's insane, right? We just want to use a chat application. So we actually built a little mini application here. It's going to come up. It's called AI-enabled search. You've got some sample questions. So let's ask something important, or something fun here. So like, what is KubeFlow? Okay. We're going to hit submit. It's going to start thinking, right? And we're going to come back and revisit this later as it processes. We're not just going to watch this load. We got other stuff to do, so let's do it. So I created some notebooks here, and these notebooks are going to show you exactly how we deployed things. Now, what's cool about these notebooks is we actually let you customize these however you want. And if you're more of a platform team persona, you can present hardened notebooks, right? You can scan these or whatever, or pin your requirements if you're more of a data scientist and you want to say, this is exactly how I built this model. Now you go build it. Here's the exact libraries I used. You can either use Condo or you can use a build process to select the actual container with all your requirements that you want to run, or maybe you want it to be specialized for running on those Intel CPUs or whatnot. You can provide all that. Not only that, but then you can say how many resources do you want. You can either have this is restricted physically based on how your cluster can scale, or you can logically restrict how much access someone has. So maybe in an individual development environment, that person's namespace doesn't have a ton of resources, but when you start to move this to staging or production or a collaborative namespace, they have way more access to compute and memory cycles. And you can tune them based off how memory or CPU are reserved, which is a whole nother conversation. You can request GPUs, you can request volumes, and it should get everything up and running for you. Another cool thing you can do is you can actually select different configurations based off this namespace. So you can say access to an S3 store, access to an object store, whatever. You can provide that for your customers, or as a data scientist, you can have this. You can just say, okay, I want to make sure I have access to maybe BigQuery or something. You can just create it and go on the fly. And again, this is just running on Kubernetes. So as long as you have the notebooks, and we can, another workshop might be building a custom notebook, you can build it and go. So once this is up, let me connect to my current environment. Load. Perfect. So again, due to time constraints, I would love to have started all this from scratch for you. But as you can see, we're already, I already created the application. I'm already asking, hey, give me a request, right? I'm already asking it. And if we do a quick some Kubernetes administration here, you can see all this is running, right? You can see the AI search application that I have. You can see my predictor. You can see my transformer. You can see my vector store. All of this is running in your namespace. So like if I was a data scientist or machine learning engineer, this is all mine. This isn't centralized. You have to grant people access. My namespace, so I can start to prototype quickly. So this first notebook, right, and this code's widely available, it's openly available, you can pull it. This first notebook, after you install your requirements, so you can go back to question answering. After you install your requirements, we got our requirements over here, including building PyTorch here from the wheels. Once you have the requirements, you actually run the first step. So this first notebook, and you're just going to run these 1, 2, 3, 4, 5, all these notebooks. This first notebook is going to take all the docs, and let me show you what we have for documents. We asked it about KubeFlow, but we could have also asked about namespace. Here's the documents we have, right? These are, in theory, right? These could be behind a firewall. These are protected documents. These are things that I'm controlling. I could be checking these in and out of source control. So you can actually start to say, what's a production document look like, which is cool. So these are my documents that I've, that we're creating, our organization's documents. We're going to take them, we're going to embed them. We're going to generate embeddings. We're going to store them in Chroma. Chroma is an open source vector database. It's great, easy to use. We're going to use the Hugging Face embedding model. This is an expert model. We talk a little bit about that more on the blog. Then we can run it and we can ask it questions. So I'm not going to run through this because I don't want to necessarily redeploy it and re-embed things for you. I don't want you to sit there and wait. Already running low on time. But eventually we take it, we store all the vector database embeddings as a file, as a bunch of files on MLflow. And then when Chroma starts up, it actually knows how to pull in those files from our endpoint, wherever it is, and load them in. For our Kubernetes fans here, we create a custom transformer using our vector store. And this is actually just an inference service. And this is just configuration as data. We say, hey, use these environment variables that we created, use the appropriate images, and provide a way to actually serve our vector database in a way that our users or our application can consume. And then once that's happening, you can test it here, and we can generate a response locally, right? This is even before you just create one inference service, so you can start to slowly improve this prototype. Okay, great. I'm getting a response. My embedding model did what it needed to do. Now it's time to go to the next step. Now the next step is we're going to, we have our vector database. We now need to have a transformer that's going to kind of act, it's going to kind of steal out all the requirements to the different components and then serve back to our application. So our application actually just hits this transformer. We create this service. We create an inference service using our custom predictor and transformer image. We create one inference service call and say, here's our predictor and here's our transformer. We go into deeper details in the blog, but what's cool about this is we have a predictor and transformer that now are aware of each other. So I have a pre-processing method within my actual model.py, and you can of course go read it. And that will automatically be aware of the URL of the actual predictor. So my application hits my transformer does the pre-processing, which is, hey, go to the vector database, get the relevant documents, and then it generates a request without me having to write custom code for my application. It generates a request, it automatically hits my predictor and comes back with the response, and then my application can serve that response. So this is just, and this is just Kubernetes manifests. For those who can maybe are thinking about it, you could check this into Git. This could be Argo, right? This could be a commit push. This is version. This is whatever you want. You can start to have a lineage of your actual API calls in your manifests. From there, we can then test before our application comes up, we can run a test. We can say, okay, give me a response. And this is going to take a sec. I'm going to take a bit here to inference. But while this is doing this inferencing locally, right, behind our environment. But other than that, and again, while that's going, here's our model.py for the LLM. If you're interested, you can take a look and see actually how this is all working. Or maybe you want to say, how did they build these Docker files? We provide the Docker files. You can check out the transformer. And from here, you can check out the transformers model.py, how we handle the build vector store, how we handle the actual pre-process. And you'll notice that it then automatically calls our endpoint, our predict endpoint. There we go. So we did give a response from our application. So everything's happy. We're all good to go. It all was within the context of Ezmeral, the Ezmeral platform, again, powered by those Intel CPUs. But the code's available. Again, these are all open source tools if you want to do this yourself. We have a lot more to come. We would love to see you at different workshops. I'd love to introduce you to other people from the content team, talk about all sorts of different workflows. Seriously, we really appreciate you taking the time to do this. This is how you can reach out to me directly with questions if you want to maybe not do it directly through the survey or you want to get hands-on. Reach out on LinkedIn and absolutely attend our next workshop where we start to improve and iterate on this and other workflows. Awesome. Thanks, everyone.